Okay, so in this video, we're still talking about random variables and transforming them, but now we're going to be kind of transforming and then combining two different random variables. So we're going to go back to Pete's Jeeps, and we are going to add another random variable that's going to involve Aaron's adventures. So here's kind of a brief little recap on Pete's Jeep tours. So his tours have a mean of 3.75 and a standard deviation of 1.0897. This was without any transformations being made. So then let's say that Pete's sister Erin decides to join the business, running tours on the same days as Pete in her slightly smaller vehicle under the name Erin's Adventures. And let's just go ahead and add that she's also doing this on a completely or in a completely different part of the country. So after a year of steady bookings, Erin discovers that the number of passengers Y on her half-day tours has the following probability distribution. So that would be a mean of 3.10 and a standard deviation of 0.943. So how many total passengers T will Erin and Pete have on their tours on a randomly selected day? So we're adding a new random variable. We're calling this Y, and that's the representing the passengers for Erin, where X is representing the passengers for Pete. And now what we're essentially doing is we're going to combine both of those random variables, X and Y, to find T. So when we combine random variables, well, it's very simple. We are simply going to add together their means. So the mean of T is going to be represented by the mean of the random variable X with the mean of random variable Y. And so we're going to do 3.75 plus Erin's average passengers. And so that's going to give me a mean of 6.85. And what this mean is representing is their average passengers per day together. So Erin and Pete together average 6.85 passengers per day. So, quick notes on that. It's very easy. So the mean of the sum of random variables for any two random variables x and y, if t is equal to x plus y, so your transformed variable is now kind of combining two variables, then the expected value of t is as follows. So in general, the mean of the sum of several random variables is just going to be the sum of their means. So then this leaves us to talking about standard deviation. So what about the variability? So how much variability is there in the total number of passengers who go on Pete and Erin's tours on a randomly chosen day? So in other words, what if we wanted to combine standard deviation? Because standard deviation is your variability. So I'm just going to add a slide so we could kind of see what we're talking about here. So it would kind of make sense as what we did before. All we did was combine their two means. So it would kind of make sense that the standard deviation for your new random variable t that would represent their combined passengers per day, well, it would only make sense that it would be their two standard deviations added together. But this isn't going to be the case. So you can never add their standard deviations. What you'd have to do is you'd have to add their variances and then take their standard deviation from that. The other problem here is that you're not always going to be able to do standard deviation. The only time that you could combine standard deviations is when the two are independent random variables. So if they're not independent of each other, you wouldn't be able to combine them. And that's kind of why I added that little thing onto our example where I said they're in completely different parts of the country. So if they're in completely different parts of the country, they got to be independent from each other because somebody can't go on both tours on the same randomly chosen day if they're on completely different parts of the country. So first, we're going to talk quickly or take quick notes about independent random variables. So if knowing whether any event involving X alone has occurred tells us nothing about the occurrence of any event involving Y alone and vice versa, then X and Y are independent random variables. So independence pretty much explaining it all, the word independence. So probability models often assume independence when the random variables describe outcomes that appear unrelated to each other. So you should always ask whether the assumption of independence seems reasonable. So like I said, it's reasonable to treat the random variables X for Pete's passengers and Y, who are Erin's passengers, as independent because they operate on different parts of the country. So because they're independent, it's okay for us to find variability or to find the standard deviation of their combined. But again, we're not going to add together their standard deviations because we are not allowed to do that. We can only add together their variances, and then we'll take the square root of that to find our standard deviation. So take your quick notes on this. So for any two independent random variables, X and Y, T is equal to X plus Y, then the variance of T is follows. So you can add variances only if the two random variables are independent, and you can never add standard deviation. So that's huge. You have to realize that. So what is the standard deviation for Pete and Erin's passengers? Well, find my little pen here. Okay, so I'm gonna write up here. Whoops, I get my pen working here. So the standard deviation for Pete was 1.0897, and so to find the variance, I'm going to have to square that. So the variance for Pete would be 1.1875. Okay, and for Erin, the standard deviation was 0.943. To find the variance, I just have to square that. And so that would be 0.89 or about. And so to combine them, I can do so because we already talked about why they would be independent. I'm just going to have to add together their variances. And this is going to give me 2.0775. And then to find my standard deviation, I'm just going to take the square root of this, which is about 1.441. And we're done. Not with the video, but with that problem. Okay. And so a quick example. A college uses SAT scores as one criteria for admission. Experience has shown that the distribution of SAT scores among its entire population of applicants is such that, and the following. So what are the mean and standard deviations of the total score X plus Y for a randomly selected applicant to this college? So for our mean, it's not defining a new random variable, so I'm just going to show that with X plus Y. And so my 519 plus 507 is going to give me, And the variance and standard deviation of the total cannot be computed from the given information. So SAT math and reading scores are not independent of each other. I think it's pretty obvious that students who score high on one part of the exam usually tend to score high on the other part of the exam. And so there's probably a relationship that goes on between them. And so you should not assume independence with these. It's usually pretty obvious as when they are independent. And in this case, they're certainly not. So moving along, let's take a look at another example. So this one has a little bit of work involved in it. So we've already defined X as Pete's passengers and Y as Erin's passengers, following its kind of some stats. So Pete charges $150 per passenger. Erin charges $175 per passenger. So we're going to calculate the mean and standard deviation of the total amount of Pete and Erin collect on a randomly selected day. So actually we have a little bit of work before we combine their total amounts. So the first thing that we want to talk about is, let's use C to represent how much Pete's going to collect. So that's going to be used with your 150 times X. We actually already did this in the first video. So I'm actually just going to put down what that was. Oops, that doesn't belong there. Okay, $562.50 and a standard deviation of $163.46. Okay, and then for Erin, we'll use G, and she's charging $175 per passenger. So for her, it would be 175 times the 310, which is 542.50. And her standard deviation, G, is going to be 175 times the 0.943 to give me 165.03. Okay, and now once I have that, I can go ahead and add together my combined means. So I have 562.50 plus 542.50. So on average, together, they make about $1,105. Okay, on a randomly chosen day. Okay, and then for our standard deviations, we already spoke about them being independent, so we know that we can do it. So I'm just going to have to first find their variances. So I'm just going to have to take their standard deviations, and I have to square them. Whoops, 165.03. Square their standard deviations for my variances. It's going to give me 53,954.07. And then for my standard deviation, I'm going to take the square root of that, and that would be $232.28 for your variability. Okay, variability in the money that they both collect together. Okay, so all you got left now, guys, is a quick check your understanding. You can essentially follow that last example that we just did, only this is maybe a little bit easier. Number 3 is like the last example. So you guys could do that on your own, and then we will check it. We will check your understanding in class.